Hi all, today we are going to see the comparison of Terraform with other IAC processing tools. So in market we have various IAC processing tools, right? So what are those? Terraform, CloudFormation Template, Azure Bicep, and Google Deployment Manager, Azure SDK, an ARM template, and a Cloud Deployment Kit for Terraform. We can shortly call it as a CDK TF, and then we have AWS CDK and Pulumi. So we have these many processing tools available in market. So to know which one is the best tool for our environment, you have to know the important differences of these tools, right? So let's see the important differences. So the first one is language support. So Terraform support Ashukop configuration language. So Ashukop configuration language is the new language which is developed by Ashukop specifically for Terraform. Okay. So if you want to write the Terraform code, then you have to know this Ashukop configuration language, but it's very easy to learn. Okay. And if you go for Pulumi and CDKTF, it will support TypeScript, Python, Go, and .NET. If you go for CDKTF, it supports TypeScript, Python, Java, .NET, and Go. So if you are good at the programming languages, these programming languages, then you can write code for Pulumi and CDKTF. Okay. AWS CloudFormation supports YAML or JSON, and ARM supports YAML or JSON. So you can write the code in YAML or in the JSON format. Google Deployment Manager supports YAML, and AWS CDK and Azure SDK, as usual, it's also support the programming language such as TypeScript, Python, Java, C Sharp for AWS CDK, and Azure SDK supports Python, JavaScript, Java, and .NET. Okay. And Azure Bicep supports domain specific language. So domain specific language is again the new tool, new language which is developed by Azure for Bicep. uh, so it is more or less the same as this Terraform. Okay. Yeah. So as we have these many IAC tools, let's see the CFT, ARM, and Google Deployment Manager, and AWS CDK, Azure SDK, Azure Bicep. These are all we are calling it as native tools, cloud native tools. Okay, and it supports its own cloud. That means you can create the resources to its own cloud. Okay, own cloud platform. But if you take the Terraform, CDK, TF, or Pulumi, it supports multi cloud platform. It means you can create resources in any of the cloud platforms. Okay, so these are main difference. Let's see the other few differences as well. So as we discussed, the Terraform, Pulumi, and CDK supports multi-cloud. So if your environment is having the multi-cloud like hybrid cloud, Azure and AWS, okay, or Azure and GCP, right? So if you have these kind of environment, and if you want to manage using one IAC tool, then the best tool is either one of these three, Terraform or Pulumi or CDKTF. Okay. Out of these three, again, if you want to choose any one, then see these differences. So Terraform, when you compare with the coding, uh, it is very easy to write the code in Terraform. Okay. Even though it is the new language, you can easily learn it. Okay, it is just a key value per language, structure based language. You can easily learn it, and the coding is very easy, and it is very understandable. Okay. But if you go for Pulumi and CDKTF, it depends on the person. So if person already very good at the programming languages such as Python, TypeScript, Java, .NET, then they may write the code. But if you are very new to programming languages, the coding part, then better go for Terraform. Okay. And when you come to the debugging, all three are very good at debugging. And community support, Terraform is having very good community support. Okay, comparatively the Pulumi. Okay. Terraform, I mean CDK for Terraform is just growing it. Okay. And if, when you come to the license part, actually these all tools are open source. It's all open source tool. In that, the Terraform is having the open source license, Mozilla public license, and Pulumi is having Apache license 2.0, and the Terraform CDK for Terraform is also having Apache license 2.0. Okay, and when you come for AWS Cloud Formation, it supports only AWS. Using CFT, you can create resources in only AWS. Okay, and coding part is easy because you can write coding in YAML or JSON. Again, it's very easy, but debugging is very moderate. Um, and community support is good. OS license, there is no license needed for it because it is part of AWS service. So if you are having AWS subscription, then you can make use of this cloud formation template. Okay, the same thing applies for ARM template and Google template manager. So ARM template, you can create resource only in Azure, and coding is easy, debugging is very moderate, and community support is strong. As usual, license is not needed because it is part of Azure subscription. Okay, and Google deployment manager, yes, you can create resource only on the Google, only in the GCP, and coding is easy and debugging moderate. Community supports also moderate because it's just growing it, and OS license is not needed at all. So when you come to the AWS CDK, it supports only AWS. That means you can create resources only in AWS platform. And coding, it's again varies to the person, depends on the person, because you should write code in Python or uh, Java, .NET or TypeScript something. Debugging, it's very good. Community support is strong. License, it uses Apache license 2.0. So Azure SDK, it supports only the Azure. And coding part, again depends on the person. And debugging, community supports are all good. License MIT. When it come to the Bicep, yes, it supports only the Azure. So you can create resources using you can create resources in Azure using Bicep. When you come to the coding part, it's very easy comparatively when you compare other IAC tools. It's same as Terraform. Okay, it's more or less the same. Okay, but only thing is using Terraform, you can manage multiple platform, but using Bicep you can manage only the Azure platform. So debugging, it's a very moderate, and community support it's just a new tool, so it's still growing up. And licensing part, it uses MIT license. Okay, yeah, state management is another important topic. You have to know how each tool is managing its state of the resources, right? So when you come to the Terraform, it is managing the state file. The state file can be stored locally or remotely. By default, it will store state file locally. The default state file name is terraform.tf state. And Pulumi, yeah, it can also you can store state file in local or remote, but by default it will store the state file locally. And that name should be like pulumi dot state stack name dot yaml. Okay, and CDK for Terraform, actually these also HashiCorp its own tool. It also uses the same as like Terraform. Okay, so yes, stateful can be stored locally or remotely, and the default stateful name is Terraform TF state, and the default location is local. Okay, and when you come to the AWS CloudFormation template or Azure ORM or Google Deployment Manager, these tools are managing its resource state internally. Okay, there is no specific state file concept, but it uses the state internally. We cannot view it; those are not visible to us. Okay, those are managed by its own cloud platform. And AWS CDK. Okay, so AWS CDK, even though you are writing code, you are writing code in Python or TypeScript, whatever it is, it will create the resources using CloudFormation template in the backend. So again, as it integrates with the CloudFormation template, So state files are managed by the cloud platform again. Okay, so it means they are managing state file internally. Okay, Azure SDK, there is no such a stateful concept, because it interacts the Azure resources directly. So if resource is available, it will create the resource. If resource is not available, it will update the resource. Okay, so there is no central stateful concept for Azure SDK. If you compare with other tools, though the other tools are first it will check the state file, and then it will check the resource, and then it will sync, and then by comparing the state file and the target platform, it will take the action. But Azure SDK it will directly interacts with the resources. Okay, and bicep, yeah, in bicep, yeah, it uses domain specific languages. But even though if you write a domain specific language at the runtime, it will generate the domain specific language into ARM template, and it will create the resource. So obviously how ARM template manage the resource, the same way it will use. So the ARM resources managing the states internally, the same way the biceps also use. So there is no central stateful concept available here. Okay, the last part is code reusability. So this is very much important, right? So the Terraform is highly, reusability. So if you write code in the module format, then the models can be reused in every places, so it is highly reusable. And Pulumi, yes, it supports the programming languages such as Python and then TypeScript, those stuff. So by default, those programming languages having high reusability concept. So so obviously by default these are having the high reusability features available. Okay, the same thing goes for CDK for Terraform as well. Okay, and cloud formation template, and then Azure RM and Google Deployment Manager, these are all very moderate. Okay, when you come to the CFT, it you have to write the different stacks and mappings, everything to make it reusable. So when compared to other tools, the reusability is very moderate. The same thing for ARM and then Google Deployment Manager. Okay, and AWS CDK and Azure SDK, as the supports the programming languages, by default it is having high reusability. Okay, and bicep, yes, again, you can write code in modules, so the modules can be reusable in I mean everywhere. Okay, Terraform. Okay, yeah. So these are the basic comparison of all these IAC tools. So yeah, thank you.